the x value of the equation, where the equation crosses the x-axis. Okay, when you hear this word root, it's just where the equation is crossing, the graph of the equation is crossing the x-axis. Okay, so use the Newton-Raphson method to find the root of the equation near the given value. So usually with this method, it's up to you first to guess which value you have to start with. Okay, now here we already have been given our initial guess, which is this one, x sub 0 equals 5. All right, so we know when we find our final solution, it should be 5 point something. Okay, because they've given us an initial starting point and an idea of what answer we are looking for. Okay, if this x sub 0 is not given, then it's now up to you to think by yourself and say, oh, which number should I start with? Okay, yes. So we have the cubic equation like this. The graph of a cubic equation is something like this, all right, almost like an S shape. All right, so where this equation cuts the x-axis, those are the roots we are looking for. Okay, where the equation is cutting the x-axis. Since it's a cubic equation, because it's to the power 3 here, so usually cubic equations have 3 roots. If it was x to the power 2, it would have been a quadratic equation and it would have 2 roots. Okay, so in this question here, we just want to find one solution for our cubic equation. We don't need to find all 3. We're just finding one solution. All right, so this is the process, these are the steps we are going to follow to get to try to find our answer. Okay. So step 1, derive the function that you've been given. Okay, step 1, derive the function that you've been given. So this is our function here, f of x equals x cubed minus 5x squared minus 4x. We need to derive this function. All right, so remember, deriving, you multiply the power, this power 3 multiplied by the number in front of the letter, which is called a coefficient. A number in front of a letter, coefficient. So since this x, we're going to assume this x, the coefficient is 1. Okay, so you assume that this coefficient is 1. Okay, whenever they just give you a letter by itself like here, just know the coefficient is 1. So you're going to multiply the power by the coefficient. 3 times 1, that is 3. Then after you've multiplied the power by the coefficient, you subtract a 1 from the power. 3 minus 1, that is 2. So for our first term, we get 3x squared. Any questions? We come to 5x squared. Same process, multiply the power. Oops, I just put my phone on the charger. 5 times 2, that is 10. Multiply the power by the coefficient, number in front of the letter. So 2 times 5, that is 10. Then you subtract a 1 from the power. So 2 minus 1, that is 1. Okay, so it's 10x to the power 1. This power 1 also doesn't need to be shown, okay, colleagues? You just leave it as 10x. Okay, if you see a letter by itself, remember that letter is raised to the power 1. Okay, So if you see in an equation where you have a y, just remember it's y to the power 1. Okay, then we derive 4x. So this x, the power is 1, even though it's not written there, it's to the power 1. Okay, so you're going to multiply the power 1 by 4, that is 4, and then you subtract 1 from the power. 1 minus 1, that is 0. So we have derived 4x to the power 0. Now colleagues, according to the laws of indices, anything to the power 0 is 1. So you don't also need to show this 4x to the power 0. Just leave it like that. Okay. So we've derived the function. That's the first thing you need to do. You derive. So if you don't know how to derive, just know you're losing marks on this question. Any questions, colleagues? Step 2. Substitute the initial guess, which is x0, into the original function and the derived function. So colleagues, remember, the original function is this one which was given in the question. Derived function is this one. So when you hear me say derived function, just remember in this question here, it's this function here. I hope we're clear with that point. When you hear me mention derived function, okay, it's this one which we got in step 1, the function we obtained in step 1. Could you mute your mic? Could you mute your mic? Okay, so remember, in this question you're going to be dealing with 2 functions. Step 2. Step 2, I said substitute initial guess into the original function. So our initial guess was x to the power 0 equals 5. Okay, it's basically your starting point, and this was given in the equation. Okay, x to the power 0 equals 5. Yes, so we're going to substitute this into the original function and the derived function. So we're going to say f of x, the original function, equals x cubed plus minus 5x squared minus 4x. Yes, so you substitute x with 5. All right, so you say f of 5. This is how you should do it even in the exam, but just don't put the steps there. This is how you should do it in the exam. F of 5 equals, so where there's x, we substitute it with 5. Five to the power 3 minus 5 multiplied by 5 to the power 5, 5 to the power 2 minus 4 times 5. Okay, 5 cubed, that is 125, minus 25 times 5, 125, minus 20. Colleagues, where it starts sounding like Greek, where I'm speaking first in English, then it starts sounding like Greek. Ask, okay? Because once you miss out any step here, this will confuse you. So I'm trying to go as slow as I can, okay? Where the confusion starts, just raise your hand, okay? 125 minus 125, 0. 0 minus 20, negative 20. Any questions? Okay, so as I said, we're substituting into the original function and the derived function. So we put it to the derived function. The derived function was 3x squared minus 10x minus 4. So we substitute x equals 5, okay? This initial guess x0. Okay, so we're going to have 3 times 5 squared minus 10 times 5. Where there's x, I'm substituting it with 5 minus 4. Uh, 5 squared, that's 25. 25 times 3, 75. Minus 10 times 5, that is 50. Minus 4. 75 minus 50, that is 25. 25 minus 4, that is 21. Okay, so we are done with step 2. Substitute into the original function and derive. Any questions before we go to step 3? Yes?
No question.
Okay, wonderful. Step 3, plug into the formula and get xi. Okay, xi just means the next values of x. Okay, put it in simple language, the next values of x. Okay, which is x1, because we started with x0, so now we're going to x1. Okay, so the next values of x. Okay, so since our initial guess was x0, all right, remember initial guess here, x0 here. Okay, so you're going to say x1 equals x0 minus f of x over f prime x. Okay, so basically what we're saying is these values we got here, when we substituted x equals 5, this negative 20 here is going to be this one here. this 21 here is going to be this one here. Okay, x0, we already have it. The question has given us x0 equals to 5. So we're going to say 5 minus negative 21 over negative 20 over 21. Okay, colleagues with calculators, give me to 4 decimal places. The reason why I'm saying 4 decimal places is because this method, okay, there are 2 ways you can know how to stop. Okay, the first way to know how to stop is when your values of x, they are now very close to each other. There are no big changes between them. Your x1, your x2, your x3, find they are very similar and very, very close. Then you know you need to stop, because you practically found what you're looking for. The other way is just to solve the equation using normal mathematics, and you get one of the roots, and then you know, okay, this is the root I'm looking at. Okay, so five minus negative 20 divided by 21.
That's 0.
Negative
95. 0.95. You said 4 decimal? 9524.
Okay, so 5 minus negative 0.9524. Negative and negative make positive. So it's the same as 5 plus 0.9524, which gives you 5.9524. Okay, that is our x1. Any questions? So the process repeats itself again. Okay, now
just before you go any further, this formula you use to find x1. Is a standard formula?
Huh?
Is this a standard formula?
Yes.
Okay. So it just has to be mastered in our heads.
Yes, because this one they won't give it to you. Okay. Yeah, so as I said, now the process repeats itself. So it repeats itself from step 2. Okay, this time that it's not your initial guess, it's now x1. Okay, substitute x1 into the original function and the derived function. Okay, so these are questions which it's a process. Okay, in the exam, after you've answered the questions you are comfortable with, you come to these ones. Not you start with this one and you start getting confused. No. So we're substituting 5.9524 into the original equation. Yes, those with calculators, I'm just from having a class with calculations, so that's why I'm asking people with calculators to just help me out with that part. And I think just give me final answers, because reading, you'll get tired reading all these numbers. Just give me the final answer. Put it like this in your calculator.
Sir, here we always the multiplication is not maybe 20x. I thought maybe it was 5x, that is the multiplication.
Oh yeah, that's the problem with x. Here 5x squared, so 5 times x squared. Someone, well, people are doing the one above, others can do the one which is below here.
For the first one, I have found 9.937.
The full answer?
Yes, the final answer.
Could it? Let's see. I have the answers for this one, so let me see. Let me use it as my reference list. And the second one?
I haven't yet started second.
or 9.84. Wait, not. Okay, that's correct, madam.
Thank you.
Second one. The second one.
I found 42.7692.
42.7692. Wonderful, madam.
Thank you.
Okay, so now you need to find x2. Okay, so we use the same formula here. Okay, this one here. So we say x2 equals x1 minus f of x over f prime of x. Okay, so we already know what our x1 is. X1 is 5.924, 5.9524 minus, so this 9.84 comes here, and this 42.796 will come there. So we're going to say 9.84 divided by 42.796. So divide, then subtract. Tell me what answer you get. What answer do you get? And it's just one person who has been answering. Colleagues, what about the rest? Remember, maths, this is a course where you have to be engaged.
Five point 72225.
All right, so the process repeats again. Okay, now we need to find x3. Okay, because at first we started with 5.9254, then we've now gone to 5.7. okay, so this tells you still need to iterate because there's a change. 5.9 and 5.7, they're not, yes, they're kind of close, but once your answers just remain on 5.7, the next, after you continue iterating and just remain with a 5.7 whatever, that's how you know when to stop. So we need to get now x3. Okay, so we repeat the process again. Okay, this 5.725, you're going to put it in the original function and the derived function. Okay, so original function f of x equals x cubed. So since we're substituting x with 5.725, so you say 5.7225 cubed minus what was the original function? X cubed minus 5x squared, so minus 5 multiplied by 5.77225 minus 4x minus 4 times 5.7225 here. And you also put it in the derived function. The derived function was 3x squared, so 3 times 5.722 squared x squared minus 10x, so 10 times 5.7225 minus 4.
The first one, it's 0.772.
0.772.
0.772.
Okay.
The second one, it has given me 37.016.
Okay, let me just confirm with resolutions here. Okay, 0.72. Okay, I got 36.93, but that was just rounding differences. So that's correct, madam.
Alright, thank you. Me, I was using it in 4 decimal places.
No, yeah. I remember I told you to leave it in 4 decimal places, yes. So that when you start, if you've got all the time to be iterating, you'll be able to see that, okay, this number is not really changing that much. Okay. Yes, so we now get x3. Okay, x3 equals x2 minus f of x over f prime of x. x2 5.7225 minus, so here you say 0.772. okay, because remember the solution you got from f of x comes on top here. Solution you got from substituting in the derived function comes at the bottom. Okay, so uh, 0.772 divided by 37.016. Can give me the final answer.
Five point 7.016.
5.7016. Okay, so you can see x2 and x1 not really far apart from each other. So you know that, okay, now I'm getting closer to the value I'm looking for. Now let me just show you the shortcut of what you can do so that you know when to stop. Okay, because in the exam you won't have time to iterate up to x5, x6, x7. You won't have all that time. Okay, so what you can do before you start even this question, before you answer it, what you can do is you solve this cubic function here. Okay, you solve it. Let me show you how to solve it. F of x equals x cubed minus 5x squared minus 4x. Let's see if I've got it correctly. Okay. So you solve this equation. you do like this. No, I didn't put that there. And you're going to say equals 0. Alright, so since we can see that every term in this equation has got an x. Okay, so you can factor out this cubic function. Okay, the common factor here is x. Okay, so you put the common factor outside. Whenever you're factorizing, put the common factor outside, x here. Alright, then you open the brackets. Okay, then you say x cubed divided by x. For those who have forgotten indices, x cubed divided by x. Remember, with indices, you just subtract
X squared.
x squared. Yes, wonderful. Wonderful. Yes, x squared. 5x squared minus divided by x.
To be 5x.
4x divided by x.
To be 4.
Yes. X equals 0. Okay. So, whenever you're found in a situation like this, there's what is called the zero product rule. Okay, after this class, go and Google this zero product rule. Okay, so basically with the zero product rule, we can just, this x outside, we can equate it to 0. So we say x equals 0. Okay, so we found one root. Okay, we have found one root. A cubic function, since the leading x variable is to the power 3, so with the cubic function you have to have 3 values of x, 3 roots. So we found one root. According to the zero product rule, one root is x equals 0. So what we remain with now, we need to solve this quadratic equation here. Okay, so that we get the 2 other roots. Okay, because we are dealing with a cubic function, so we need 3 solutions of x. Okay, so we solve this quadratic equation to get the value of x. Alright, so we check, can we use the factoring method for to solve this quadratic equation? Let's see the factoring method.
Yes.
Okay, factor it out for me.
If we use the rest for factoring, like we find the sum, the product, and the factor.
Yes, where you do like this. First multiply a times c. Okay.
Yes.
Colleagues, what I mean when I say a times c, a is this coefficient of x squared. Okay. B is the coefficient of x. C is the constant. Okay. So when I say multiply a times c, that is, so a equals 1 in this case, because the coefficient of x squared is 1. B equals -5, because the coefficient is -5 for x. And c equals -4. The coefficient, c is the constant. Okay. Yes. So when you want to try to solve a quadratic by factorizing, you multiply a times c, 1 times -4, -4. So we have to look for 2 factors of -4. Okay, 2 factors of -4. That when you multiply them, they should give you -4. Those 2 factors should give you -4 when you multiply them. And when you add them, they need to give you -5. Okay, 2 factors of -4, when you multiply them, they give you -4. When you add them, you get -5. Now I already tried this question. You won't be able to find those factors. Okay. You won't be able to find, because you can try. If you say, okay, let me use these two factors, -1 and +4. 1 times -4, it gives you -4. But 1 plus -4 doesn't give you -5. Okay, you can try 1 and -4, +1 and -4. You multiply to give you this -4. If you add, it won't give you -5. So you have to use the quadratic equation. Okay, remember the quadratic equation? -b plus or minus b squared minus 4ac over 2a. Okay. So you say -b, so you say negative, b is -5 already, so you say -5 here, plus or minus b squared, -5 squared, minus 4 times a, which is 1, times c, which is -4, over 2a. Okay, those who have got lost, colleagues, what I'm doing here is we just want to see what answer we're going to be looking for when we do those iterations we are doing. Okay, we just want to see, okay, what answer we are actually looking for, so that you don't need to iterate 5, 6 or 7 times. Okay, then over 2 times a, 2 times 1. Okay, so this becomes negative and negative make positive, so 5 plus or minus. Okay, I hope you are not regretting taking maths. Okay, colleagues, are we enjoying the mathematics? I hope no one is saying, why did I do this course? Honestly, why did I do this course? Okay, once you enjoy mathematics, it becomes easy. Okay, but once you tell yourself, mathematics, no, this will start looking scary. So -5 squared, that's 25, minus 4 times 4, that is 4. 4 times -4, that is -16. Over 2 times over 2. Okay, so homework, colleagues, finish solving this quadratic equation. One of your roots is going to be 5.7. Okay, just finish solving this, and one of your roots will be 5.7. Yes, madam? It's going to -0.7.
The other one, since there are 2. The other one will be positive 5.7, and the other one will be negative 0.7.
Yeah, so that 5.7, so you have already solved, madam, huh?
Yes.
Colleagues, let's clap for her. Like, that is very impressive. I think let's not be jealous. That was Madam who?
shared.
Yes, so that's correct. You get two solutions. One is 5.7. 5.77 what?
7016.
Uh-huh. And the other one is what?
Negative 0.7016.
Yes. So colleagues, the root you are looking for in this question here is this one here. That's why you're doing all of these iterations. So once you know you're looking for that, you can even just end on this third iteration here and just say, oh, this is my solution. You don't need to do a fourth iteration, okay? Yes. Any questions?